let's get on to a really fun topic, password cracking. There are a number of methods and all sorts of targets, so let's get started. Where will we find passwords? Well, in an operating system, in Windows, there is something called the Security Accounts Manager, the SAM. It's a file that is loaded into the registry when the machine boots, and it contains all the usernames and passwords. That's in Windows. If your Windows machine is a member of a Microsoft Active Directory domain, that database is something called ntds.dit. It stands for New Technology Domain Service, ntds.dit, and I can't remember what DIT stands. Data Information something. Or if you're in Linux or Unix, there are two files. There's something called passwd, which is where the users are, and something called shadow, which is where the passwords are. It used to be that the passwords were just simply in passwd, but as they had to get more secure, they split the two off. You can find the SAM in Windows System 32 config. You can find Active Directory in Windows System 32 NTDS, I think. Well, it used to be where it is. You can find passwd and shadow in root in the etc directories. So these are your main things. Now, it is true that applications might have their own little password files, but these are the main targets. So what is password salting? Well, let's talk about a password. Now remember, a password is normally some string of letters and numbers, characters, that a user enters. They put in their username and they put in a password, right? Now, some passwords are kind of short. They should be long. Or maybe you've made them a certain length, you've required a certain length, but the longer a password is, the harder it is to crack. It's actually orders of magnitude harder to crack. So in order to take a password, even if it's an okay password, and make it even longer, and make it random, we add just a little bit. We call it a salt. It's just a random string that you add to the password. Now, we know what it is. Nobody else knows what it is. I mean, the user doesn't know, but the operating system knows. Take the password like this, add a salt to it, then hash the whole thing. The salt makes the password just longer and more complex. That's the whole purpose. A good salt is something that is never reused. Every user has their own. And every time the password's changed, there's a new salt. So it's just to randomize and make the password longer and thus more complex. So salt is additional random data added to a user's password before it is hashed. It lengthens and randomizes the password, making it harder to crack. Salts should be unique for every user and never reused. Now, of course, we know, especially if you've ever dealt with small office, home office routers like Linksys and TrendNet and D-Link and those kinds of things, we know that most devices have default passwords. Not necessarily operating systems, I mean, not like Windows, but most devices have default passwords, and you can find them on the internet. And there are many sites that you can search. 40poundhead.com, cert.net, opentextsays.me, defaultpasswords.in, defaultpassword.us. I mean, this is just a few. Everybody knows that, hey, what's the default password for this router? Oh, admin, look it up. So you can search for default passwords. Why is this significant? Because lots of folks forget to change the default. They leave the default. I mean, that's what Shodan.io is all about, finding internet-facing things. And you can go in and look at cameras and look at what the camera sees because somebody forgot to change the default. So let's talk about basic password attack types. Let's start with the good old dictionary attack. In a dictionary attack, you have an automated tool, a password cracking tool, that goes through a list of words. A dictionary is simply a long list of passwords. And this automated tool will start with a username, such as administrator, and it will try this long list of passwords. going through the whole thing. And the hope is that the password is in that list. Now, if you think that's silly, it's not, because people tend to select the same easy passwords. Do a search on the internet for the 1,000 most commonly used passwords, and you'll be amazed. There are dictionaries that you can download from the internet that have 1 million passwords in them, 15 million passwords in them. Chances are excellent that people's passwords are in that dictionary. So the dictionary attack is simply start as administrator, go through the long list. Might take a couple days, and see if there's finally a match. You can well imagine that in a dictionary attack, if the user you are trying to attack, if they have a lockout policy after like 3 bad attempts, obviously a dictionary attack is going to lock them out quickly. But what's the one account that can never be locked out, ever? It's always exempt from policy. You're right, the administrator. And in Linux, it's root. So those accounts are privileged. They'll never be locked out. So you can dictionary them all day long, all week long. Of course, you're probably likely to set off intrusion detection, but maybe your target doesn't do that. So the hope is that the list is large enough so that it will contain the password, because users like to choose easy passwords. And we have researchers on the internet that have spent years putting together word lists. Word list is another word for dictionary. There are, of course, practical limitations. You need to know the username. Although you can also have a list of possible usernames, and that can be in a list by itself as well. So what will happen there is I'll have a list of possible usernames: administrator, admin, something, 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 or names that I've social engineered, or names that I've scraped up based on my OSINT passive research. So I have that, and I have my big old dictionary of possible passwords. And starting with the first user, let's go through the list. Starting with the next user, let's go through the list. Or they mix them up sometimes. So that's what you can do with a dictionary attack. So the word lists, they can get unwieldy. I mean, so like, for example, it is not uncommon, especially with the rainbow tables, to have 1.5 billion words. Now, I hope your password is in 1.5 billion words. That's a 15 gig uncompressed dictionary. That is huge. Very unwieldy. And of course, there will be lockout policies on authentication systems. You could bypass the dictionary attack. You could just steal a copy of the database file or the password file that has the credentials, and you could just crack it quietly offline. You could coax the system, or more like inject something into the system, get it to dump hashed passwords out of memory or to extract them out of a file. You could intercept an authentication, like when someone's logging on across the network, you could intercept it, we'll talk about that later, and send that hash that you've captured to a password cracker. You could run a cracker against the network service that does not do lockouts. You could run a cracker against accounts that are exempt from lockout, like administrator or root. Now, a fancy type of dictionary is something called the rainbow table. In a rainbow table attack, this is where the passwords in the word list have been pre-computed into their corresponding hashes, then compressed in a highly efficient manner. Where rainbow tables are useful is for offline cracking. Now, what this means is if you are trying to do cracking across the network to a web server, rainbow table probably doesn't help you, because the web server is expecting a username and a password. You know, passwords are very seldom, I hope never anymore, stored in a file in clear text. They should be hashed. And what that means is we'll do a one-way computation on the password and have a resulting jumbled up fixed length thing called a hash. It's a one-way encryption function. So in this way, the operating system never stores the original password. Instead, it takes a hashing algorithm like MD5 or SHA-1 or MD4 or something. And when the user saves their password, It runs the password through that hashing algorithm. Out comes this hash, and it stores that. Then when the user logs on, it just takes the input from the user, runs it through the same hashing algorithm, and just compares the two results. If they're the same, user must have used the right password. Great. That's usually how passwords are stored, because hashes are infeasible to reverse engineer. You basically have to have words like a dictionary, compute them into a hash, and then just see if the hash matches. Well, if you steal a password file with hashes, you steal the SAM, you steal ntds.did, you steal etc shadow, etc passwd. If you steal those and you just try to run a cracker against them, if you didn't have a rainbow table, you would have to, for every dictionary word, calculate the hash and then try it. And then it's a comparison. Well, a rainbow table has all those dictionary words that are pre-computed. So it's just going down the list real fast. And the way they do the algorithm of pre-computation is they don't actually have individual hashes like that. They actually compute and recreate on the fly. So they're very, in terms of space, very, very, they're just resource good. They don't, they're efficient in terms of space utilization. So you have a rainbow table. It's a special type of dictionary with pre-computed hashes. It makes offline cracking much faster. You use it against a stolen file of password hashes. And it has a special reduction function that reduces the size of the table. You could have a 64 gig rainbow table with 70 trillion hashes. Man, if your password isn't in there, I don't know what. On the other hand, a 64 gig normal dictionary could only have 6.5 billion passwords. So we're talking huge orders of magnitude difference. It also requires less computational power than a plain text dictionary. Although you are computing sort of the hashes as you go, it has a really clever algorithm. You don't have to compute every single hash for every single word. So computationally, it's less work. There are password crackers that can use rainbow tables as well as ordinary dictionaries. But some of the rainbow table ones are OffCrack, Rainbow Crack, and KPEC. You could also do what's called a credential brute force. Just simply, if you don't have a rainbow cracker and your dictionary isn't good enough, you just try combinations until you find the password. This is a really tough one, and you prefer not to do this because this one is what will take up all your time and make it actually infeasible to break a password. You're better off with a gigantic dictionary. If the password's really short, like a 4-digit PIN, well, that's okay. You can go through that in a couple minutes, maybe even seconds. The longer the password gets, the harder brute forcing becomes. So again, if brute forcing isn't feasible, try to steal the hashes, try to steal the password list, or try to intercept the login that a user might use. And because password cracking is so CPU intensive, there are some tools where you can offload the task. Like John the Ripper, which is a well-known password cracker, can actually organize multiple computers to work at the same time. There's another one called Hashcat that can use the graphics power of your graphics card, because all the advanced graphics cards, like the NVIDIAs, they have a built-in CPU, but they call it a GPU, a graphics processing unit. So they can offload some of the work on the GPU. And there are online password cracking services. Here are just a few of them. You can just upload the hash and give them a day or two, and they'll send you back something. Now, you realize when you're doing that, they're doing that so that they can collect a huge list and just add yours to the list. And maybe what you've submitted to them is something they've already seen. So there's a trade-off there. But if you're hacking, maybe you don't care. So here's an example of onlinehashcrack.com. You just upload whatever file, or you just paste in the hashes. You pick the algorithm. You give them an email. You do a CAPTCHA to prove that you're not yourself an automated process. And look at this. I mean, they'll do Wi-Fi and Office and a bunch of other things. And they'll email once they have a result. So that is a background on password cracking.